Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Arabat College, University of Delhi. So in our previous lecture we have taken one example of a company database and we have seen how to design a complete entity relationship diagram right from the scratch. So for the purpose of practice here in this lecture, before going to the architectures for database management system, we are going to take one more example of a particular scenario in which we need to draw a complete ER diagram, and the scenario here is a very familiar scenario, which is a university database example. Let us understand the problem first. So the problem here is, in a university, a students enrolls into the courses. These students must be assigned at least one or more courses. So there can be a student which can take more than one courses, or there can be a student which is going to take only one course. Then each course is taught by a single professor, and to maintain the instruction quality, the constraint here which is being put up is a professor can deliver only one course. So from this particular scenario, from these constraints, we are going to kind of identify what are the entities, then corresponding attributes, and then the relationships between them. So as we have seen these constraints or the problem definition, where we have students enrolling into the courses, professor teaching the courses. So basically there are three entities: one is the student, another one is course, and third one is professor. So the entity identification is actually, you can say, is not a very difficult task. And as far as relationship identification is concerned, we have seen the student is assigned a course and professor delivers a course. So there is a relationship between a student and a course, and there is another relationship between professor and the course. So here, if we are going to see them in a we can say collective manner, so a student is assigned a course, so the relationship between them is assigned, and course is being we can say delivered by a professor. So course delivered by professor. So this should be kind of the structure here, we can say, of entities and relationships. But we also need to identify the attributes of the entities, which are student, courses, and professor, and we also need to see whether there are any attributes which are associated with the relationships, because the relationships can also have the attributes, we can say. Apart from that, here one thing which we have not identified till now is the cardinality. Cardinality as in is it a one-to-one relationship or one-to-many relationship, and so on and so forth. So for cardinality identification, the problem statement we have seen is stating that a student can be assigned multiple courses. So there is going to be simply we can say it is not a one-on-one, one-to-one relationship, but a professor can deliver only one course. So if a professor can deliver only one course, that means the relationship between the professor and the course is going to be one-to-one, while the relationship between the student and course, now one student can take multiple courses, and there are courses in which in courses we have more than one students. So both the sides of entities are having we can say many sides. So a student and course is having a many to many relationship, and now unlike the previous example, the cardinality here is being represented with the help of crowfoot notation, and in the previous example I taught you the representation of cardinalities using the letter allotments, or the we can say symbol allotment. And while the relationship between the course and the professor is actually one to one. Now after identification of relationships and your we can say entities, we need to identify the attribute also. And in the previous lecture I was saying that how to identify the attributes in a practical real life scenario, that is something which we need to kind of how are we going to do that. So for identification of attributes or for identification of these kinds of things, one need to study the documentation like files, forms, reports, and the data which is currently being maintained by the organization in order to identify the attributes. This another idea or a supplementary idea here is to conduct the interviews with various stakeholders in order to identify attributes and entities. And also it is important to identify the attributes initially without mapping them to a particular entity, and then subsequently those attributes can be mapped to various entities. And also here, while mapping attributes to the entities or even to the relationships for that matter, one must ensure that an attribute is to be paired with exactly one entity. It should not be like that an attribute is belonging to more than one entity. If this is the scenario that your attribute is belonging to more than one entity, we need to use a modifier in order to kind of make it more unique, we can say. So here once this relationship and entity mapping is done, we have identified some attributes also. We need to identify the primary key, or we can say we need to identify the unique key. Even if the unique key is not readily available, one must need to create. So for example, in case of a student ID, in case of a student as an entity, we have primary key as a student identity, a student ID, the attribute, other attributes along with this is one is a student name, and there can be many others. Then for professor, we have a professor ID or employee ID, we can say. Then other attributes are professor name and address, salary, there can be many other. Then for course, we have a course ID and the name of the course, and along with the name of the course we can have total number of hours for which this particular course is being taught and from which particular location it is going to be taught. So apart from primary key, there can be many other attributes attached or associated with an entity, as we have seen here. Now here, even if I am taking just for the sake of simplicity of the representation, I am taking only one we can say attribute along with the primary key. So for a student, it is going to be student ID and the student name, where student ID is the primary key. A student is being assigned courses, many to many relationship as discussed earlier. Then course ID and course name are there. Course ID of course is a primary key, that's why it is being underlined. For a professor, it is an employee ID or professor ID, as I told you, underlined because it is the primary key, and we also have the professor name. So this is what we can say is actually a very simple example of diagram using this university database, or we can say whatever is given in the problem, from that particular problem we need to extract the entities, we need to kind of map the attributes, we also need to see the relationship, and then finally we can create one particular consolidated diagram. So it could be in this form, or we can have this in the form of a complete graphical representation in which the entity is being represented with a rectangle, and then the attributes are represented with the oval, and this is what the with the example which we have seen in the earlier lecture. So till this point we have seen two examples, one in the earlier lecture and one in this lecture, of how to draw an diagram which is we can say right from the starting. Now there are some specific remarks which are, we can say, do's and don'ts while designing an diagram, and that's an important That's something to be that is important to be considered. So let us see what are these do's and don'ts. There should not be any redundant entities or redundant relationships. If there are any, we need to remove them. All the entities and relationships are properly labeled, otherwise it is going to create a confusion. Also, we need to make sure that an ER diagram supports all the data to be stored. We should not leave any details unattended from the problem statement. Each entity, as I have told you, should not be kind of redundant. It should only appear a single time in the ER diagram, and every relationship, entity and attributes are to be named and labeled properly, and there is no need to connect two relationships each other. These relationships are there in order to connect the entities. It could be a recursive relationships. For example, we have seen the relationship of employee managing employee, or employee supervising employee, that is one employee supervising many employees. So that could be one of the kind of, we can say, recursive relationship. That is okay, but we should not connect, we should never connect the relationships to each other. So that is something, these are kind of, we can say, do's and don'ts while designing ER diagram. So till this point, by the level of detail which we have considered for ER diagram, right from database modeling, why they are necessary, then the elements and each and everything we have seen. We have also seen two examples. I am sure that you are kind of, you have got the ER diagram in a quite detail, and you will be able to design a sensibly good ER diagram if as and when required. Now, moving towards the second topic in this lecture, which is about the architectures for database management system. So this says that database management system, when hosted on in a particular system, or when implemented for a system, how what kind of architectures we can have. So there can be two types of architectures. One is centralized and another one is the client server, and within the client server we can have a two-tier architecture, three-tier or n-tier architecture. So let us see what is actually this centralized architecture and the your client server architecture. So centralized architecture, so previously recall the good olden days in which there was a mainframe computer which is there as the main processing center, and for this was the processing system for all the functions, including user application program, user interface program, also for the DBMS functionality. That means in the centralized architecture, your mainframe system is hosting the database management system. The whole processing is being done there for each and every task, and the users are going to access these that particular mainframe via the computer terminal. Now, when I am saying computer terminal, that means there is no processing power. So it's we can say it is only kind of a display terminal. So users are allowed to access such mainframe systems via the computer terminal, which are not having any processing power, and these display terminals are connected to that central mainframe computer via various type of communication networks. So DBMS itself was, we can say, a centralized functionality which is being hosted by that mainframe. All the DBMS functionality, application program execution, user interface processing, each and everything was carried out on one particular mainframe. But gradually these DBMS systems started to exploit the available processing power at the user side, which led to client server DBMS architecture. Now see what has happened. The prices of hardware has declined, and then what has happened, each and every user terminal, which was the only display terminal till this point, has started going into, or has been started converting into a full-fledged, we can say, computer which is having its own processing power. So now the users which are connected to that mainframe computer along with through the help of computer networks. Earlier these users were having only display terminals. Now these users are having we can say full-fledged computers with processing powers. So earlier when these were only terminals, the whole DBMS, its all functionalities, whole application program execution was residing on the mainframe, because display terminal was not having any processing power. But if we say kind of when these terminals have started converting into computers with processing power, DBMS systems started to exploit these processing power which is available on the user side. And then what happens, the client server DBMS architectures came into the picture. But before going into the client server DBMS architecture, let us first try to understand the centralized architecture with the help of a figure which is given on the screen. So here you can see there are display monitors. These are only just the display terminals, as I have told you. Then these are connected to the central mainframe computer which is shown in the in a big rectangle. And that mainframe system or these display terminals are connected to the mainframe system with the help of communication networks. It is shown in the figure. And then this big rectangle which is representing your mainframe is having one layer of hardware or firmware. Then we have a layer of operating system onto it, and then various softwares are being kind of hosted. And you can also notice database management system also hosted among along with various other softwares onto this mainframe. So this was actually the architecture earlier, which is being called as the centralized architecture. Now moving from this centralized architecture, as these terminals have got some display, as these terminals have got some processing powers, these central architectures started getting converted into client server architecture. So what is happening in a client server architecture is these architectures are developed to deal with computing environments in which there are large number of PCs, workstations, file server, printer, database server, web server, email server, and other softwares, equipments which are connected via network. So for example, we have file server which is going to serve the different files to the whole network. Then we have a database server which is there for the database functionality, and for the database functionality all the clients are going to kind of we can say contact this database server, or for managing the emails we have a different server, or for managing the web applications we have one web server. And all the we can say other computers which are personal computers, workstations are connected to these different servers. So here we have a specialized server with specific functionalities. For example, as I have told you, file server to maintain the files of the client machine, printer server for which is there to ensure the printing, or which is there to be connected to various printer, web server or email servers, are also kind of a specialized servers which are there for hosting and execution of web applications and email applications. And the resources which are provided by these specialized servers are to be accessed by many client machines, and these client machines provide the user with appropriate interfaces to utilize these servers and their functionalities. And not only those interfaces, but these client machines are also there to provide the local processing power in order to run the local applications. So there are some local applications which are available on that client machine, that's a full-fledged PC, and also it is having an interface which is going to allow them to use these specialized server, for example your mails mail server or something of that sort. So if we want to see a logical logical figure of this client server architecture that is shown on the screen. So we have various clients which are connected to various servers via a particular network, and also these clients are also having their own we can say processing power. Now one thing more which is worth noting here is this is actually known as two-tier client server architecture. Now why this is known as two-tier client server architecture? Because the one tier is client and another one is the server side. Moving on to we can say a different kind of architecture will be which we will be seeing in a short while is three-tier architecture or n-tier architecture. So for example, in this two-tier architecture, client is having some of the kind of we can say limited functionality of its own, but if it requires access to the additional functionality, for example database access or email server that is not existing on its own machine, it will connect to the server in order to have that functionality. And that server is actually we can say is a system which is having both hardware and software that can provide services to the client machines, and these services are in a wide range like file access, printing, archiving or the database access. Now this, as I have told you, this is a two-tier client architecture. Now moving on to a more complicated architecture, it is about the three-tier architecture or n-tier architecture for web, specifically used for web applications. So many web applications use an architecture which is known as a three-tier architecture, which adds an intermediate layer between the client and the server. Now it could be a database server or whatever. So here we can see on the screen that there is we can say two type of or two terminologies of this three-tier architectures are being shown. So one is the client is having a graphical user interface or the web interface. Then the second layer comes up as the application server or the web server, which is having application program and web pages onto it. And another one, the last layer, is about the database server, which is hosting database management system. And now why I am saying two two architectures with different terminologies. So intermediate layer or middle tier in the between is known as application server, or depending, or we can also call it as the web server. That depends upon what kind of application we are using. Then this is going to play an kind of mediator role by running the application programs and storing business rules. So all the business procedure constraints which are used to access the data from the database are stored on the middle layer, and it can also improve the database security by checking the client's credentials. So client is going to log in. The procedure constraint security checks are available on the second tier, which is the application server or the web server, and then the request is being transferred to the database server. So basically it accepts the request from the client, process the request and send the database query and send commands to the database servers, we can say. And then this also acts as a a conduit for partially passing the processed data from the database server to the client, and then the further processing is being done at the different ends. And presentation layer is there to display the information to the user and allows the data entry. Business logic layer, if we talk about, it handles intermediate rules and constraints before the data is passed up to the user or down to the DBMS. And then the bottom layer, which is the last layer, includes all the data management services. Middle layer is acting as a web server which retrieves the query result from the database server, format them into dynamic web pages which are viewed by the web browser at the client side. So this in this way we we can understand the three tier, or maybe we can say n tier client architecture. So, in this lecture we have seen one example of university database in which we have designed the whole ER diagram, and in the second part we have seen the architectures for database management system, which is client server and DBMS, and within the client server we have seen 2-tier architectures and also 3-tier architectures as well. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. Take care. Goodbye.